Okay, Bismillah, alhamdulillah, wa salatu wassalamu ala rasulillah. Today, inshallah, we will learn how to sketch the graph of secant and cosecant. Tangent and cotangent next class, inshallah, because of the quiz, we didn't have enough time to do that. طبعا, you need to remember what is the domain and what is the range of these kind of functions. As I asked you at the beginning, Shabab, do you know how to sketch the graph of sine and cosine? And you said yes. Most of you, they said yes. If you know how to sketch the graph of sine and cosine, you will be able to sketch the graph of secant and cosecant. So easy. And they are related to each other, as we will see. What is also in common between secant and cosecant and cosine and sine, that they have the same period. The period is 2π. You know also, for example, if you want to sketch the graph of secant, you should know that secant, it is the reciprocal of cosine. It is 1/cosine. And we know that cosine x is a bounded function between -1 and 1. And that this make, of course, the absolute value of cosine less than 1. Because secant, it is 1/cosine, the absolute value of secant will be greater than 1. And this means, as you know, that secant, it is greater than 1 or less than -1. And this, of course, makes the range of this function. The range is from -infinity to 1, union from 1 to infinity. Now, if you don't know how the graph of secant looks like, what you will do? It is natural to think about plotting points. What is the problem when you plot these points? Look, for example, at 0, what is cosine 0? Cosine 0 is 1. 1/1 is 1. What is cosine π/4? It is 1/√2. So secant will be √2. At π/2, we have a problem. At π/2, cosine will be 0. So this will be 1/0. So it will be undefined. The same situation will happen at 3π/2, at -π/2, at -3π/2, and so on. If you try, Shabab, now to sketch the graph by plotting points, you can see that it is not easy at all. Look, at 0, it is 1. This is 1. At π/4, this is π/4. At π/4, it is √2. √2 is greater than 1, like here, for example. At π/2, it is undefined. So it means that we have a vertical asymptote here. It is undefined. At 3π/4, it is -√2. So it is like here, -√3/2 here. At pi, it is -1. So let's say -1 is here, -1 here. And you can continue. At 3π/2 here, it is undefined. But if you want to plot these points, it is not easy, Shabab. It will be, by the way, let me tell you something. It will be something like this. Something like this. But it is not easy to decide. So what is the best way to sketch the graph of secant is to recall the graph of cosine. Do you remember the graph of cosine? This is the graph of cosine, Shabab. The period is 2π, from 0 to 2π. What we have here, Taman, this is at the middle. Here we have π. Here we have 3π/2. Here we have π/2. And the maximum is 1. The minimum is -1. Now, this is the graph of cosine. What you will do to sketch the graph of secant, you will ask yourself, this is the x-intercept. Here we have the x-intercept of the graph of cosine. This means that cosine here is 0. Cosine here at 0. Cosine at π/2 is 0. So what we will do here, we will draw a vertical asymptote. So now these will be the vertical asymptotes that we draw here. Look, these are the vertical asymptotes of the graph of secant. Now, at each top, this is a top, this is maximum. At each maximum, draw a cup. Draw U opens up. At each minimum here, at each bottom here, draw a cap. U opens down, and so on. Then say thank you for the graph of cosine. You will have the graph of secant. That's it. So easy. Look. So what you will do, you will start with sketching the graph of cosine. This is 6.3. Then erase this graph, and what is remaining is the graph of cosine. This is of course over one period. If you want to go also to the right, to the left, you can of course continue. And notice that it is U-shaped. The graph of secant, it is U-shaped. It is just about U opens up and down. What is the most important feature in this graph? The vertical asymptotes. Where they happen where cosine is 0. Whenever cosine is 0, you will have vertical asymptotes. Now, to describe this function, this is the domain, Shabab. All the real numbers except pi over 2 plus n pi, which if you make it a single fraction, it will be like this. It is about pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and so on. This is, of course, the domain, the range, I mean. This function is discontinuous at the zeros of cosine, so it has their vertical asymptotes. No x-intercept, Shabab, for the graph of secant. Look at it. The period is 2 pi, as the same as cosine. No amplitude, no minimum, no maximum, because of course it goes to infinity and to negative infinity. And of course it is symmetric about the y-axis because it is even. For cosecant, the same. For cosecant function, it is the reciprocal of sine. Sine is between -1 and 1, so cosecant will be greater than 1 or less than -1. Again, if you tried plotting points, it will not be practical. So what is the best way to do is to sketch the graph of sine. Do you remember the graph of sine? This is the graph of sine. Now here, at each x-intercept, you will have a vertical asymptote. So here, we will have here a vertical asymptote. This is a vertical asymptote, a vertical asymptote, a vertical asymptote. At each top, we will have a cup. At each bottom, we will have a cup. And here we are. This is what we have. This is the graph of cosecant. Remove now the graph of sine. No need. It is just a guide, ya shabab. It is a helper. Notice the vertical asymptotes, where they are. They are at 0, pi, 2 pi, negative pi, negative 2 pi, and so on. Again, of course, there no x-intercept. Of course, they are no maximum, no minimum, no amplitude, and so on. In general, and of course, the vertical asymptotes are at n pi. What is n pi? N pi are the zeros of sine. It is, of course, odd, so it is symmetric about the origin. This is secant x. Look at the reflection when we have negative secant x. What happens? What was above the x-axis, it becomes below the x-axis. So it is about the reflection in the x-axis. The same for cosecant. They may look similar to each other. By the way, it is not easy to distinguish between these 4 functions. Some of you, they said, oh, this looks like this. Look, cosecant, it looks like negative secant, but it is not indeed. Look at the vertical asymptotes here, what they are, and here where they are. And here, this cup is between 0 and pi. This cup here is between pi over 2 and 3 pi over 2. So yes, they may look like each other, but in fact, they are totally different. Now, the graphs of secant and cosecant functions are U-shaped branches. Of course, this is clear from the graph. Now, as before, ya shabab, when we have sine x or cosine x, the period was 2 pi. This is the period. When we have, of course, sine kx, it is 2 pi over k. The same here for cosecant and secant, even if we have vertical stretching and shrinking. So also you remember, we usually sketch the graph from where to where? From 0 to 2 pi. Here we will draw it from 0 to 2 pi over k, the same idea. Just, I think in the case of cosecant, we have a problem there. So we will make it open, because at 0 and at 2 pi over k for cosecant, we will have sine equals to 0. So there will be a vertical asymptote. Let's see how to sketch now the graph of a half cosecant to x. What to do to sketch the graph of this function, Shabab? what we will do to sketch the graph of this function?
Find the amplitude first.
We will graph the function of a half of sine 2x. This is cosecant. Cosecant, it is 1 over sine. So I will draw this and forget about this now for a while. How to sketch the graph of this function? You need to find, for this function, you need to find the amplitude. The amplitude is what, Shabab? The absolute value of 2 of a half, so it is a half. So now when I sketch the graph, what I will do? I will make this here a half. Let me do it right here. A half, this is a half. This is negative a half. Okay? Now, what is the period? The period is 2 pi over 2. So what is it? Pi. So this means that we will draw the function from 0 up to where? Up to pi. Okay? We know that we draw from the 0 to the period. Now, what is the graph? The graph is for sine. Sine without reflection. So sine without reflection, if you remember, Shabab, here it is. So now, this point, this is pi, so this is pi over 2. Now, what we have, at each x-intercept, we will have a vertical asymptote. Now I finished sketching the graph of sine. So what I will do now, I will sketch the graph of cosecant. Now, at each x-intercept, here sine is 0, so we have cosecant undefined. And here we are. Now, at each top, I will draw u opens up, here u opens down. Now, I will say thank you for sine. Now, this is the graph of cosecant. So easy. Okay? How to find the vertical asymptote, ya Shabab, without sketching the graph? This is a very important question. It is very repeated in all the exams. So if the question was just about the vertical asymptote, what you will do to find the vertical asymptote? You will ask yourself when this function is undefined. This will be undefined at the zeros of sine. So what are the zeros of sine? Yani sine 2x is 0 if what? If 2x equals what? N by. What is n by means? 0 by, 2 by, 3 by, 4 by, and so on. Solve it for x, ya Shabab. Divide by 2, it will be n by over 2. So now what is n? N is an integer. It is 0, positive or negative 1, positive or negative 2, and so on. So now look, if n is 0, what you have? You have 0. When n is 0, we have x equals to 0. Here it is, this one. If n is 1, what we have? What n equals to 1? X equals to pi over 2. Here it is, this one. If n is 3, we will have x equals to 3 pi over 2. When n is 2, why 3? Let's start with 2. When n is 2, you will have x equals to pi, which is this one. And continue like this. You can go to the left, you can go to the right. So easy, so clear. Now, ya Shabab, this is the graph. This is the one that we sketch. It was like this. This is the one that we sketch at the beginning. You can, of course, repeat the process by the same way. And then at each top, draw a cup. At each bottom, draw a cap. Is this clear, Shabab? Now, how to sketch the graph of this function? To sketch the graph of this function, it is better to write it in the standard form, k times x minus b. So you will take 2 as a common factor, and here we are. Now, it is, ya Shabab, very practical to compare this graph with this. The one that we started here, the one that we sketched here is what? It was what? It was this one, a half of cosecant 2x. This one, it is the same as this one, but shifted what? What is the amount of shifting? Pi over 4 to the right or to the left? It is not pi over 2, ya Shabab. Be careful. Here, it is not pi over 2, the shifting. Because we still have the coefficient of x here is not 1. It is pi over 4 to the left or to the right, ya Shabab?
To the left.
To the left. So what does that mean? This is 0. It will go to here. It will become here at negative. Let me show you, for example. What was at 0, it will become here at negative pi over 4. What was at pi over 4, now this is the vertical asymptote. What was at pi over 2, it will be here at pi over 4. So now these are the new vertical asymptotes. Now the same shape will be here, and you can continue. So if you shifted, just draw it by shifting, this is what you will have. Look, this branch, here it is. This branch, here it is. So you can, to sketch the graph of this function, you can start sketching this graph, the graph of the function of this one, then shift it to the right, to the left, I mean, by amount of pi over 4. But I know that most of you, they don't prefer that. They may do mistakes. So how to sketch the graph of this function without shifting, as it is? I'm asking, how to sketch the graph of this function, alone, without comparing with this. Forget about this. How to sketch the graph of this function?
Cosecant is 1 over sine.
The answer is to sketch the graph of sine x plus pi over 4. This is the answer. Sketch the graph of this function, and you know how to do that from 6.3. What you will do, what is the amplitude? The amplitude is a half. The period is what? 2 pi over pi, which is over 2, which is pi. Now we have a horizontal shift here. The horizontal shift, how to find it? As clearly it is negative pi over 4. If you solve this one for x or this one, you will get. Now, what is the interval that we will sketch the graph on? We will sketch the graph from where to where? From the period, from b to b plus the period. From negative pi over 4 to negative pi over 4 plus pi. What is that? 3 pi over 4. So now what I will do, I will go here. I will sketch the graph starting from negative pi over 4 up to where? Up to 3 pi over 4. Okay? Let me put it a little bit to the right. Here we are, 3 pi over 4. Now, what we will do, Shabab, we will find the fourth of the period. What is the fourth of the period? The fourth of the period is, this is the period, it is pi over 4. Now, what I will do, I will add pi over 4. So pi over 4 plus negative pi over 4, we will be here 0. Then pi over 4 here. If you add pi over 4, you will be here pi over 2. Here we are. Now we will sketch the graph of what? We will sketch what is the maximum. The maximum is a half. The minimum is negative a half. What I will do, I will sketch the graph of what? Of sine. You know the graph of sine. It looks like this. Check, is there reflection? No reflection. So it is like this. So here we have midline, maximum, midline, minimum, midline. So midline. At this point, we'll have maximum. At this point, we will have midline. At this point, we will have minimum. At this point, we have midline. Connect them. This is the graph of sine that we are looking for. Okay. Now, what I'll do, I will sketch now at each x-intercept. When sine is 0, we have vertical asymptote. When sine is 0, we have vertical asymptote. When sine is 0, we have vertical asymptote. Now, at each top, draw a cup. At each bottom, draw a cap. Remove this. Thank you, sine. Now, this graph is the graph that I'm looking for. This is the graph of my function, cosecant 2x plus pi over 4. Is it clear, Shabab? I will assume that this silence means yes. Now, if you want, if you want to sketch the graph of secant and cosecant, I advise you, as I said, to sketch the graph of sine and cosine. But if you want, you can sketch this graph alone, by the way, but it is not easy. So you need to find the period, the interval that you will sketch on. You need to find the vertical asymptote. How to find the vertical asymptote? The zeros of cosine, the zeros of sine, of course. And don't forget the reflection. I advise you, Shabab, to follow the method that I showed you to sketch the graph by starting with cosecant. I assume that you can know now this. You can sketch this, Shabab. It is not difficult at all. So to sketch this, what we will do, we will sketch the graph of 3 cosine, a half of x. We will draw this. This is, Shabab, not equals to this. It is just a helper. It is a guide graph. So to sketch this graph, you know that the amplitude is 3. The period is what, ya shabab? 2 pi over what? Over a half. So it will be 4 pi. Now we will, from where to where, there is no horizontal shift, we are lucky. So we will start from 0 up to 4 pi. So let's go directly to there. So we will sketch now the graph from 0 to 4 pi. The midpoint here is 2 pi. Here it is pi. Clear. Here is 3 pi. Now the maximum is 3. The minimum is -3. This is the graph of cosine without reflection. So do you remember how it looks like? Maximum, midline, minimum, midline, and then maximum, like this. So these are the 4 points that we have. So here we have maximum, ya shabab, here midline, here minimum, here midline, here maximum. Connect them. This is the graph of cosine. Now to sketch the graph of secant, what we will do? At each x-intercept, we will have a vertical asymptote because cosine is 0 here. Then at each top, we will draw a cup, and each bottom, we will draw a cap. You can continue, of course, if you want, but this is enough for one period. And this now, thank you for the graph of cosine. Now, this is the graph that I'm looking for. As I said, you can continue this way, you can continue this way, and so on. Wala ashal ya shabab. So easy. Is that right? Are you still with me, ya shabab, or I'm alone over here?
Yes.
No,
We are with you.
So say something, please. Now, ya shabab, الزبدة. The summary of this section is here, of this part of this section. If you need to graph in general, even if you have vertical shift, usually we don't focus on that, ya shabab, but even if you have vertical shift and all the kind of transformations horizontally and vertically, there is no amplitude for these graphs because there is no maximum or minimum, unless, of course, they give you specific interval. The period is 2 pi over k. The horizontal shift, as we did before, the vertical shift. What is important, ya shabab, here is this, the vertical asymptotes. The vertical asymptotes, ya shabab, how to find them? In the case of cosecant, they are the zeros of sine. So both the argument, both what is inside equals to n pi. In the case of secant, they are the zeros of cosine, which is pi over 2 plus n pi. It is better to write it this way, ya shabab. Here it is 0, here it is 0 plus n pi, here it is pi over 2 plus n pi. The domain is all the real numbers except the vertical asymptotes. Now, also this part is important, the range. When you have secant x, what is the range? Is from -infinity to 1, union from 1 to infinity. Now, if we multiply by a, if we have a secant x, a could be positive or negative. The domain will be from -infinity to the negative, here it is -1, by the way. And here it is to the negative absolute value of a, union from the absolute value of a to infinity. Now, if we have a and we add c, okay, we will add c here also. So it will be from -infinity to negative the absolute value of a plus c, which is this one. So in general, when you have, this is the vertical shift, ya shabab. What is this? This is the vertical shift. What is this? This is the amplitude of sine and cosine. The maximum and the minimum for sine and cosine. Now, again, this is the summary. Now, I want you, ya shabab, to solve, we want together to solve this one. Please take a pen and paper and start solving this one, and I will launch a polling for you so you can vote. Please, the question is about the sum of all the vertical asymptotes. So we need now to find the vertical asymptotes. No need, ya shabab, here to sketch. You can sketch. One way is to sketch the graph. This one, sketch the graph of sine, this graph. Do it, please, if you want. Then you can find the vertical asymptote. What is the problem here? That he wants the vertical asymptotes. Not in the first interval. No, He wants them in this interval. He gives you specific interval. So you need to find the vertical asymptotes in this interval, then sum them up. Geometrically, you can sketch the graph, and you know how to do that. Please try to do it. But there is an algebraic way. It is very nice. And I'm sure that you may prefer this method. But if you prefer the geometrical method, no problem. For those they want to use the geometrical, the algebraical method, let me give you a hint. What is this, Shabab? It is cosecant. Vertical asymptote, it means undefined. So cosecant is undefined if the sine of x over pi over 3 equals to 0. If this is equals to 0, we will be in trouble here. So sine whatever equals to 0. If this whatever is what? Sine what equals to 0, Shabab? If sine theta equals to 0, what is theta?
0.
0 only?
0 and 180.
By 2 by 3 by 4 by negative 2 by. How to write all of these? N by. What is n? N is in integer. So here we will say this will be undefined. This will be undefined if x over 3 minus pi over 6 is equals to n by. What is n? N is 0, positive or negative 1, positive or negative 2, and so on. Now solve this equation, ya shabab, for x. X equals what? If you find x, you will have here all the vertical asymptotes. Now check which one of them is here in this interval, and you will solve the question so easy without sketching the graph. So do whatever, ya shabab, you want by solving this algebraically or geometrically. Geometrically, we have showed you 3 or 4 examples, so you can do that. What I will do, I will solve it algebraically for you, but not now, after you finish. I give you the hint, you can now solve it. MashaAllah, I have seen 2 students voted so far. MashaAllah. Superheroes. I don't know how you did that. Anyone, Shabab, who answered so far, who tell me how he obtained, which method he used? I have 2 students select the right answer. Which one, Shabab? If you answered, tell me what is the method that you used. Three students, they obtained the right answer, but they didn't show up. Raise your hand if you choose the right answer so far. We have 3 students. It is just by guessing, ya shabab, so you are playing and you are not practicing. Unfortunately, you are not practicing. No grades on this, ya shabab. It is just kind of practice. So why you select the answer just to guess or to just select the right answer? The idea is how to know how to solve, not how what is the correct answer. I know what is the correct answer. You should know how to obtain it. Okay, 5 students so far. We still have, of course, no one show me what is the method that he used. Do you use the graph or the equation? Geometry or algebra? Hello? Let's give you more time, Shabab. Now, what we will do, let me continue this. Let's continue this method. because I'd like to mention it, because also we will use it next class. So here we will solve this equation for x, ya shabab. So we will move this to here. Now multiply by 3. It will be pi over 2 plus 3n pi. What I did, I just multiply by 3. I solve it for x. What are these, ya shabab? These are all. What is n? N is 0, positive or negative 1, positive or negative 2, and so on. These, ya shabab, are all the vertical asymptotes. Here, these are all vertical asymptotes. Okay, we don't want all of them. We want just the ones that they are here in this interval. How to know? There are two methods. Let me show you here the first method. Okay, if n is 0, what you will have? Let me do it here. If n is 0, what we will have? What we will have here, shabab?
Pi over 2.
X will be pi over 2. Is it in or out? Is it in this interval?
In.
It is in. It is in this interval. Let me call this interval I. So it is in I. Okay. This interval, I will call it I. Now, if n is 1, what we will have? Both n equals to 1. Here. This will be 3. 2 times 3 is 6. 6 plus 1 is 7. So x will be 7 pi over 2. 7 over 2 greater than 2, ya shabab. So it is not. It is not an I. So stop. Don't try n equals 2, because of course it will be bigger and bigger. So you have stop here. So only 1? No. You didn't try negative 1 and negative 2 and so on. So try negative 1. If x is negative 1, what you will have? It will be negative 3, negative 6, negative 5 over 2. Negative 5 pi over 2. Is it greater than negative 4? Yes, it is n. Try n equals negative 2. If you tried n equals negative 2, what you will have? Negative 6, negative 12, negative 11. Negative 11 pi over 2. Negative 11 over 2 greater than negative 4. In fact, 11 over 2 greater than 4, but negative 11 over 2 is less than. So it is not. Now we will stop. So who are the winners? Here, this one. So the vertical asymptotes that we are looking for, here they are, this one and this one. Sum them up, ya shabab, you will get the right answer. Let me end the polling and share with you the results. طبعا the result, the right answer is C, as most of you select. Now, if you add this plus this, you will get negative 2 pi. Now, ya shabab, what is if you are lucky, you will get the right answer from 0 and 1, negative 1, and so on. But sometimes they may give you far away n. You need to do many n's to find that. So what is the better? There is a better method that we can use for this. What is it? It is to ask yourself, where is x? هذه الاكس يا شباب. الاكس الآن أنا أبغاها فين? I want this x to be between 2 pi and negative 4 pi. Is that right? So this is the x يا شباب. Right here, pi over 2 plus 3n pi. هذه هي الاكس. This is x. I want it to be 2 pi, between 2 pi and negative 4 pi. Now solve this for what? For n. Solve it for n. Solve this inequality for n to know which n you need. We need to know which n we need. So plus 3n pi. Now what I will do, I will add pi over 2 to negative pi over 2 to both sides. So it will be 2 pi minus pi over 2. And here negative 4 pi, negative pi over 2. Now simplify 3n pi less than or equals, what is this? 2 pi minus pi over 2, it is 3 pi over 2. And here we have negative 8, negative 9 pi over 2. Continue here. Let me continue here. Now I need to solve it for n. What is n? What is n? So I will divide by 3 pi. N will be what if we divide by 3 pi? N will be pi will gun 3 with gun, we will have a half. Greater than or equals pi with pi, 9 over 3 is 3, so it is negative 3 over 2. Now do you remember what was n, ya shabab? N is what? N is integer. So what are the integers between negative 3 over 2 and a half? What are the integers between negative 3 over 2 and a half? N equals what? Negative 1. Is negative 1 there? Yeah, Shabab, look at the numbers line. This is -2, this is -1, this is
Yes.
0, this is 1. So this is, here we have -3/2. Here we have a half. So the integers that they are between -3/2 and a half, they are -1 and 0. So look, they are the ones that we used before. The same ones. So without trying other n's, I know exactly what is my n. You can now, if they ask about what they are, you can go back here. Now these are the n's. Go back here, both n equals -1, both equal to 0, then sum them up. But mostly, ya shabab, in most of the questions, they will ask about the number of the vertical asymptotes. How many vertical asymptotes? Now we know from here that we have 2. But these are not the vertical asymptotes. These are the numbers of n that at them we will have vertical asymptotes. The vertical asymptotes are here. These are the vertical asymptotes. These ones, not these. Is this clear, شباب? How to find the vertical asymptote? طبعا لو كان هذا السؤال secant كنا بدل الn لو كان if it was طبعا الشباب اللي they sketch the graph, you can of course do that, why not? But we have sketched several graphs, no need. Now my question is, شباب, what about if it was cosecant? What will be the difference? Secant, if the graph was like this, what will be the difference? Just you will put pi over by x, not pi. You will put x over 3 minus pi over 6 equals to what to find the vertical asymptote, ya shabab? Equals to pi over 2 plus n pi, not n pi. And you can continue by the same way. Let me give you a final question, shabab. What is the domain of, what is the range of this function? If you know. The hint, we have a formula. When you have y equals to c plus a, secant, whatever, the range will be like this. So according to that, who can tell me which answer is the right answer? In this case, what is a, what is c? What is a?
C is -½ and A is
No, C is 1. C is 1. Be careful. And A is -½ It's -½ Be careful. So what? So the range will be from -infinity to
-3/2.
So the absolute value, let me take the absolute value. So it will be -½ plus 1 closed union from the absolute value plus 1 to infinity, which is -infinity to a half closed union 3/2 to infinity. Look at this easy question. The answer is A. Thank you, Shabab. Thank you, guys. See you, inshallah, on Sunday. Have a nice weekend. And if you have any question, I have time. I still have time to answer your questions. Try, Shabab, to prepare for the midterm during this weekend, please.